Hi, and thanks for joining me in this video about structural icing. Structural icing, of course, being the ice that's accumulated by an aircraft. Right now, we're working our way through the different hazards that aircraft experience.
The next hazard that we'll talk about is propeller ice. Aircraft that are certified for flight into known icing conditions have propeller blades that are de-iced or anti-ice. They're protected. If you are flying an airplane that is not certified for flight into known icing conditions, then those propeller blades are unprotected. And as a result, you're going to have an accumulation of ice on those propeller blades. Not only does ice build up on the propeller blades, but also it builds up on the propeller hubs and spinners. The combination will result in a reduced thrust from the propeller, but the only indication the pilot gets is a reduction in airspeed. The pilot won't really see a change in the RPMs of the propeller because if you have a constant speed prop and you set it at a certain RPM, the governor will try and keep it at that RPM, and you really won't notice a decrease in your propeller speed. It'll be the same. You'll just have a decrease in the propeller efficiency. The next hazard we'll talk about is visibility. An airplane that is not certified for flight into known icing conditions does not have windshield protection for ice, which means that if you're flying through icing conditions, the windshield will ice up and you won't be able to see out the front to identify the runway when you come in for a landing. Airplanes that are certified for flight into known icing conditions do have windshields that are protected. And those protection systems are either an electrically heated system where there are little wires that run through the windshield that heat the windshield, or it may be just a portion of the windshield that has heat, such as a hot plate. Or perhaps if you're flying a turbojet, they'll take some of the hot air from the compressor section and run it through to the windscreen to keep the windscreen clean of ice. When you're in moderate to severe icing, your de-ice or anti-ice for the windshield can't keep up, and as a result you'll get an accumulation even though you have your de-ice or anti-ice on. This is an indication that you're in supercooled large drops. Visibility out the windshield is an important consideration, especially when you're flying IMC, when you're flying instruments. Here's an accident that occurred back in 1992. A Piper Arrow flying from Grand Forks, North Dakota. They were on their way out to Las Vegas. But along the way, they encountered ice. It was forecasted to be moderate icing conditions. The airplane started picking up ice, and the pilot needed radar vectors right away to the nearest airport. The nearest airport was Evanston, Wyoming. And the pilot shot the approach, broke out at about 1700 AGL, and was not able to see the runway. So they circled in VFR conditions at low below the clouds and tried to scrape off the ice with a credit card using the little storm window. That didn't work very well because the pilot was, of course, distracted trying to scrape the ice off the windshield, and the airplane descended below the elevation of the airport. The airport sat up on a bluff. So the airplane impacted the ground. Everybody walked away from the accident, but it just gives you an indication of the problems you'll have if you fly an airplane into icing conditions and the airplane is not certified for that. Here's the weather for the accident, and it shows that there was 3 miles of visibility. Also, it shows that there was a scattered layer down at 300 feet AGL, but it was overcast at 1,700. So they had good enough visibility to see the runway, and they were not in the clouds. So the only problem they had was trying to see the runway with a coat of ice on the windshield. The next hazard that we'll talk about is the problems that aircraft have when their instrumentation gets coated with ice. Instrument icing is another problem. Instrument icing is when any type of instrument on the aircraft ices up, whether it be an angle of attack sensor or outside air temperature gauge. Also, pitot-static systems. The pitot tube typically sticks out and picks up ice. But these are small objects, and small objects, as you know, ice up first. When these small objects on an airplane ice up, they will disable the systems that they operate. For example, the pitot or the static ports on an airplane, if they are covered, then you won't have altimeter, you won't have vertical speed or airspeed. Other problems that can happen, objects that ice up will start to vibrate if they're sticking out. A good example is antennas, especially the whip antennas. Blade antennas don't vibrate as much, but whip antennas, as they start to accumulate ice, they will start to vibrate back and forth to the point where they may weaken the backing structure of the fuselage where they're mounted just because of the vibration and the fatigue of the metal. And as a result, the antennas may depart the airplane. And when they depart the airplane, they may strike another part of the airplane and disable that also. So this is a hazard, getting ice on these instruments. If you're flying in icing conditions, airplanes that are certified typically do have some sort of ice protection, but not every part of the airplane is protected from ice. There are critical systems on the airplane that need to be working even if you're in icing conditions. And one of them, of course, is the pitot tube. And that, most aircraft do have anti-ice for the pitot tube. In other words, it's called pitot heat. You turn on the pitot heat before you enter icing conditions or any type of possibility of ice. And that's what anti-ice is. Anti-ice prevents ice from forming. The last hazard that we'll talk about is SLDs, and we'll talk about how to visually identify SLDs if you're in icing conditions. SLDs, of course, are supercooled large drops. They have high momentum because they have lots of mass, so they tend to strike areas aft of protected airfoils. So if you see ice on parts of the airplane that don't normally pick up ice, past the de-icing boots, past the heated wing, then you've got problems. You're probably in in a cloud that has supercooled large drops. Also, if there are rivulets or ridges of ice on the windows or on the side windows where droplets are streaming back, then you're probably also in SLDs. Another indication of SLDs is if you have an unusual extensive ice coverage over the airframe. So if you see ice where you don't normally see ice, if you're flying in icing conditions and you're looking out on the wing and other parts of the airplane and you're seeing some really strange structures of ice, more than likely you're probably in SLDs. These are just a few of the hazards that pilots will experience when operating in icing conditions. And pilots need to use good risk management skills to keep their aircraft and their passengers safe.